here.
Usually if it's not on the bottom, it's on the back.
Same thing we have to do from the last time is we have to go from a name to a formula so we can create a balanced chemical one. So sodium we know, but acetate you guys looked up for me.
Is with CH3CO2.
You guys have it as CH3CO2, which is the same as CH3COO. And sometimes they write it C2H3O2. All of them are correct because they're the same things. I'm going to always write it CH3COO, and that's because what it looks like is this.
Are we going to be doing that soon?
You will. It's in the unit called Organic Chemistry. It's coming up. So the reason I write it CH3COO is because it's CH3COO. I remember how it's drawn, and that's why I write it that way. That's why most people do it that way. You don't have to. All of the other ways are acceptable, but that's the reason why. That's the reason why I write it CH3COO, because it just gives you a little bit more information than the other ways, but they're all right. So whatever it's on your chart, you can write it as. Okay, just be aware. It's 1 minus, I believe. Am I right? CH3COO. Sodium was 1 plus. We went through that in the last video, so if you need a tip on that, look at the last video for how we do that. Potassium chloride is potassium. IDE tells me it's not a polyatomic, it's just chlorine. And since potassium is group 1, it's 1 plus. Chlorine is group 7, it's 1 minus. You can look that up right on anything. So those are balanced. Again, normally you would write on one line, but just I don't have the space. So I'm going to do it this way. All right. I have 1, 2, AB plus CD. So once again, what type of reaction are we thinking? Double displacement. So we're going to move sodium and chlorine together, outside with outside. And potassium with acetate inside. This one's real easy for us because it's 1 plus 1 minus 1 plus 1 minus, so I don't have to worry about it, but always check yourself to make sure that once you switch partners, they don't just always go. The subscripts don't always stay the same. We have to then compare charges every time that we do that, just like naming. But in this one, 1 plus 1 minus 1 plus 1 minus, we're okay. So we have two things left to do a balanced chemical equation. We have states, or we have balancing. Balancing is done. If I was to look at Na, CH3, COO, K, Cl, on the reactant side and the product side, I have 1, 1, 1, and 1, and 1, 1, 1, and 1. That was pretty easy. So balancing was easy. For the test, you're welcome to write ones, but typically in chemistry, if there is a 1, we don't normally write it. I'm just going to clean this up because I need this space for something else. It's coming. So let's look up states. Acetate is one we don't see a lot. Is that soluble or not soluble typically? Acetate is soluble and sodium is soluble as well, so that's there. Chlorines you may remember or you may not remember from the last one. Soluble as well. Chlorine is soluble and potassium is not an exception. That means this one's soluble because sodium's not an exception, and we said acetates are all soluble, so that one is all soluble. Which leads me to a question. Did anything actually happen here?
No.
No, and the reason why, and this is where going back to the last test, and we'll see this a little bit in our labs going forward, it's called the total and net ionic equation. So if I was to write this, aqueous just means water gets in between those two. So if sodium acetate is soluble, it means that when I put it in water, water takes that sodium and pulls it apart. And it takes that acetate and it pulls that apart. And what we actually end up with is sodium by itself, surrounded by water. That's what AQ means, aqueous. It's Latin for water, aqua. And CH3, COO, 1 minus, aqueous. And potassium is aqueous, so it's like this. And chlorine is aqueous like that. And that's what it really means to be aqueous. And if I look at the product side as well, well, sodium chloride is aqueous, and so sodium is aqueous plus, oh, sorry, it's with chlorine now. Chlorine, which is aqueous, plus potassium, which is aqueous, plus acetate, which is aqueous. Now, if I look at the things before, the reactants, and I look at the things after the products, is there anything different about the reactants and the products? Let's see. The first thing I wrote here was Na plus aqueous. Do I have that at the end of the reaction, Na plus aqueous? I do. So I'm just going to put a cross through it because we counted it. It's the same on both sides, before and after. So I'm just going to put a cross through it because it didn't change. ch4c, 1 minus, acetate aqueous. Do I have acetate aqueous after the reaction finishes? Yeah, it moved. It's not in the same order, but it's still there. So I could have written this any order I want. It's still there. I'm going to put it across just because it's the same. It didn't change at all. How about potassium 1 plus aqueous? It's right here and right here. So I'm going to put a cross through that because it didn't change, so it's still the same. And what about that leaves chlorine 1 minus aqueous? It's the same too. So if I was to just write down all of the things that are different about this reaction, I get nothing. There's nothing different. If there's nothing different before a reaction, quote unquote, and after a reaction, there was no reaction. Nothing changed. Nothing changed at all. And so that's why if you have aqueous in all 4 spots, we say that no reaction occurred. So this is what you're going to come up with. The one trick for those is you actually wouldn't write that. You would then say, or you could write it all, but I want you to recognize that that means that no reaction occurred. That was the trick for your test last time, is knowing that understanding. Understanding that, it's not a trick, it's just the knowledge, but knowing that would allow you to figure out barium sulfate from that question and barium nitrate from that question. Well, the sulfate's not soluble. If you put barium in and sulfates there, it falls to the bottom, it's a solid. But if you put barium in with nitrate, it still dissolves. So by the question telling you that when you mixed barium in this solution, you got a white precipitate, you just have to look up, see which one's solid, which one's not. And that would tell us, oh, sulfate must be there. Because if it's not, then nothing is different. We don't know. So that's that.